students, welcome again to my lesson. Today I'm going to teach you all about dimension analysis. This is class by Raj teaching for Physics Form 6 Semester 1. Our learning outcome for today is to check the homogeneity of equation using dimensional analysis.
Class is to check the homogeneity of an equation. Example is, I have an equation S equals to ut plus half at squared. Okay, I have a equation. Okay, an equation in physics is true if any system of units. The dimension of physical equation is homogeneous if all the terms in the equation have the same dimension. So you see here, in this equation, there are three terms. First term, second term, third term. So these are the three terms. Term 1, term 2, term 3. Okay, so three terms. Okay, you can also put lah, but I'm just telling you there are three terms. Okay, if an equation is homogeneous, okay, homogeneous, if an equation is homogeneous, all the three terms must have same dimension. All three terms must have same dimension. Okay, like for example, let's find one by one. Okay, the dimension of S. Okay, S is a distance, so the dimension of S is L. Okay, alright. Okay, dimension of UT. Okay, now what is the dimension of U? U is initial velocity. So initial velocity, the dimension will be LT negative 1. T, the dimension of T is capital T. So therefore, we solve this. Okay, our index. So T negative 1 plus 1 will be T0. So we get L. Okay, next we find the dimension of the third term, which is the half at squared. Okay, now the dimension of this, when you see a half. Okay, what is half? Half is called as non-dimensional constant. Okay, this is actually a number. So this is a constant. So it's a constant. So when it's a constant, it's a numerical value. It is a non-dimensional. That means it's called as non-dimensional. Non-dimensional constant. Okay, that means it doesn't have dimension. So therefore, we only find the dimension of at squared. So the dimension of A, from what we have studied just now, from the last lesson, sorry, at negative 2, the dimension of T is T, and then you have square, you square, you square, you square. So you get what? L T negative 2 T squared. So what do you get? L T negative 2 plus 2, you get L T 0. So you get L. So from here, you realize that the dimension is same for all these three terms. Okay, so what we can say is, we can deduce is, this equation is homogeneous. Okay, this equation is homogeneous, or we can say this equation is dimensionally homogeneous. Okay, so that is the meaning of, to check the homogeneity of an equation is by finding the dimension of each term. Okay, now we know this equation is homogeneous, but whether this equation is correct or not, okay, whether this equation is correct or not, if the equation is correct or not, you have to go through experiment. Okay, the validity of an equation is confirmed by carrying out an experiment to investigate the relationship between the variables in the equation. So if you want to know if the equation is correct, this equation, you have to do experiment in order to see how the relationship of all those physical quantities. Okay, then if you have done the experiment and you realize that all are actually related to each other, then you say the equation is correct. Okay, now let's look at another example or another situation. Okay, now I have an equation. Okay, S is equals to UT. Okay, plus 2AT square. Okay, so we have how many terms? We have here got one term, 2, 3 terms. Okay, so it says that an equation is homogeneous if the equation, every term in the equation is same dimensional, correct? So what we do now, we find the dimension for S. The dimension for S is L. The dimension for UT is LT negative 1 T. So I get LT0, which is L. And then I get 2AT square. Okay. Then 2 is a non-dimensional constant. So I find for AT square, A is LT negative 2, T square is T square. Okay. Round bracket, yeah, round bracket. So I get L. Okay. Alright, so in this you realize that the dimension for this term is L. This is L. The dimension for the second term is L. The dimension for the third term is L. So what can we say? We can say the equation is homogeneous. Or we can say equation is dimensionally homogeneous. Okay, but is the equation is correct? That one we cannot identify unless if you do the experiment. An experiment has done and they found out all the formulas are all the physical quantities are related in such a manner. So that means this equation is incorrect. This equation is incorrect. The correct equation will be this. Okay, so because when they do the experiment, they found out the relationship of the physical quantities and the non-dimensional constant are in such a way, not like this. So an equation, okay, the dimensional homogeneity of an equation does not confirm that the equation is correct. So even if it's homogeneous, these two equations, it doesn't mean that the equation is correct. Why? Because in this example, the reason why the equation is not correct is because of the non-dimensional constant. You see? Alright? So, the value of the non-dimensional constant in the equation is wrong. That's why the equation is incorrect. Okay? Now, another way of doing it, another example of explanation. S is equals to half a t squared. Okay, I find the dimension of S. Is L. I find the dimension of half a t squared. So half is a non-dimensional constant, that means no dimension. So a will be LT negative 2, t will be t square, so you get L, t 0, so you get L. Okay, in this example of formula, it is homogeneous. The equation is dimensionally homogeneous. But is the equation is correct? No, the equation is not correct. Why? Because the equation is incomplete or contain incorrect terms. The terms actually for the relationship of distance with acceleration and time will be in this way. Okay, so this will be the only correct equation. Okay, so in this case, the equation is incorrect because of no equation is incomplete. This equation is not correct is because of non-dimensional constant is wrong. This equation is correct because of they are homogeneous and they went through by the validity of the equation is confirmed by carrying out an experiment to investigate the relation between variables in the equation. So this is homogeneous and correct. So what I'm trying to say here in this lesson today is that an equation is homogeneous if all the terms in the equations are same dimensional. But an homogeneous equation doesn't mean the equation is correct. Okay, like in this example, this equation is homogeneous, but it is correct because why? This equation has gone through by carrying out an experiment. Okay, it has gone through a process of experiment to investigate the relationship of all those physical quantities. Okay, this equation is homogeneous but is incorrect. Why? Because the term is incomplete. Okay, and this equation is homogeneous but is also incorrect because why? Because the non-dimensional constant is wrong. Alright, okay, that's all class.
The summary for today's lesson is: the dimension of a physical equation can be homogeneous and non-homogeneous or not homogeneous. An equation is homogeneous if all the terms in the equation have the same dimension. Whether if the equation is correct or incorrect is only confirmed by carrying out an experiment to investigate the relationship. Just because an equation is homogeneous, it doesn't mean the equation is correct.